More praise for antique books. John Tyndall's Radiant Heat, Part 2. Blue Skies. Of the numerous memoirs in my antique copy of John Tyndall's 1872 book, Radiant Heat, two are particularly memorable. The first, Memoir 1, the subject of my Part 1 video, describes the absorption and emission of gaseous vapours when irradiated with radiant heat, the invisible rays beyond the red wavelengths of the visible spectrum. His results strongly suggested the mechanism by which the Earth maintains atmospheric heat control, what we now know as the greenhouse effect. This video focuses on his Memoir 10, which describes an unexpected result when selected gaseous vapours were irradiated with light from the violet-blue end of the visible spectrum. The experiment produced what Tyndall called an artificial sky. It is now known as the Tyndall blue sky effect, and it opened up new areas of investigation by leading physicists of 19th century Europe. Why is the sky blue? A question asked by many an illustrious thinker. As John Tyndall acknowledged, the idea that the colour of the sky is due to the action of finely divided matter, rendering the atmosphere a turbid medium, through which we look at the darkness of space, dates as far back as Leonardo da Vinci, with speculations by Newton, Goethe, Clausius and others. In 1868, continuing his study of the effects of radiation on gaseous matter, Tyndall switched from infrared wavelengths to the shorter wavelengths, that is, the violet-blue end of the visible spectrum, and their action on the vapours of various volatile liquids. After experimenting with coloured light filters, he had concluded that blue rays are the chemical rays which had the greatest chemical effect on the vapours, and of all the experimental outcomes, the most significant was the scattering of incident light by the vapours to produce an artificial sky. Here's how he achieved it, with what he called a simple apparatus. And he was right. It was simple, but good enough. In his own words, the first distinct record of this appearance occurs in my notes for October the 10th, 1868. When the light first passed through it, and for some time afterwards, the experimental tube appeared perfectly empty. Slowly and gradually, however, upon the condensed beam a cloud formed which passed in colour from the deepest violet through to blue and whiteness. To this record of my notebook, the remark is added, "Connect this blue with the colour of the sky." And he concluded, "The incipient actinic clouds are to all intents and purposes pieces of artificial sky, and they furnish an experimental demonstration of the constitution of the real one." Tyndall ascribed the blueness of the sky to the scattering of light by minute particles, but didn't advance any explanation for why it was that particular colour. However, his results spurred great interest in the upper echelons of physics, and just 2 years later, Lord Rayleigh, a future Nobel Prize winner, mathematically modelled light scattering by the water vapour. He pursued this topic over many years, culminating in his 1899 paper. But whether the scattering agents were the individual molecules of the atmosphere, or the number-density fluctuations of the air's molecules, became a contentious issue for many years, even involving, yes, you guessed it, Albert Einstein. To put it mildly, mathematical modelling was not John Tyndall's forte. I could find only one inconsequential equation in my copy of Radiant Heat. Nevertheless, I think he would have appreciated Raleigh's formula for the scattering effect on a single wavelength light ray by a very small object. The scattering effect, Rayleigh found, was proportional to a fraction involving the wavelength, to the 4th power of the wavelength, as a matter of fact, and its significance to blue skies. To appreciate this little expression, let's take the ratio of a blue light ray, wavelength 45 micrometers, to that of a red light ray, wavelength 65 micrometers. The scattering effect, blue light to red light, is equal to 4.35, which means blue light bounces around the atmosphere over 4 times that of the less scattered red light. and that's why the sky is blue. On behalf of the team, thank you for viewing this video.